Each year during the winter months, road salt becomes a necessity in order to go about our everyday lives. It is used on major highways, in cities, and in suburban areas so that people can safely travel the roads. It's estimated that anywhere from 17 to 22 million tons of salt are used for de-icing roads in the United States each year. That's equivalent to about 137 pounds of salt per person in the United States. However, road salt was not always the response to dangerous winter storms. Early attempts at snow removal in the 1800s solely involved citizens going into the streets and shoveling. Snow removal was crucial to communication and the dispersion of food and other supplies. In order for residents or merchants to travel by carriage, they were responsible for clearing the roads themselves. Patents of snowplows were issued in the 1840s, and among the first few involved using a plow attached to a cart with several horses. Salt was actually used in a few cities at this time, but there were strong protests against it because it made it difficult to sleigh and it ruined people's clothing. In an effort to limit the use of salt, streets and bridges were coated with sand instead. Cities became involved with snow removal by hiring horse-drawn carriages and shovelers to work alongside plows. They hauled away the plowed snow and dumped it into rivers. This not only cleared the huge amounts of snow, but it created thousands of jobs throughout the winter season. Before the 1940s, highway departments still mostly relied on plowing and abrasives such as sand and cinders, small pieces of partly burned coal or wood, in order to keep roads safe for traveling. At this time, salt was primarily used only as an additive to prevent sand piles from freezing. The continuous increase in population, industrialization, and the creation of roadways called for more effective means of de-icing for safe travels. During the winter of 1941 into 1942, New Hampshire became the first state to begin using salt as the primary means of de-icing roadways. Since then, road salt use has been increasing rapidly. So what is road salt and where does it come from? Simply put, it's sodium chloride. Road salt is actually the same salt we use on our food, except it's less processed and purified. Road salt is usually mined from underground layers of the earth in the form of crystals. Miners use dynamite and powered shoveling machines, along with conveyors and crushing machines, to process the salt. There are salt mines all over the United States and the world, including Detroit, New York State, Kansas, Louisiana, Mexico, Chile, Egypt, Ireland, and Australia, just to name a few. Road salt has a huge impact on the economics of society. In a study by IHS Global Insight, they estimated that a one-day shutdown from a major snowstorm and impassable roads would cause a loss of $300 to $700 million in some states. They claimed that snow-related shutdowns harmed hourly workers the most, accounting directly for 2/3 of the economic loss. Retail and businesses could also be impacted due to the fact that people won't travel to buy products in the snow. There are also the costs that come along with accidents due to a snowstorm, such as car damages and health-related injuries. Road salt can decrease the chances of crashes by up to 88%, injuries by up to 85%, and accident costs by up to 85%. Road salt makes the roads safer for traveling, thus reducing the risk of these economic costs. However, this also comes with a cost. State and local agencies spend more than $2.3 billion annually on snow and ice control operations. Salt contracts can sometimes be tricky in the sense that towns must pay an 80% delivery acceptance rate in the middle of the summer, even if they don't end up needing all the salt that they ordered. There are also long-term costs of using salt on the roads because it is such a corrosive substance. It is estimated that corrosion costs $3.5 to $7 billion per year in the United States. Road salt is capable of damaging concrete on bridges and parking garages, eroding structural reinforcing rods, damaging vehicle parts such as brake linings, frames, and bumpers, and it can also damage power line utilities. Road salt is not only damaging to a variety of infrastructure, but to water quality as well. Road salt can enter our water resources by infiltration to groundwater, runoff to surface water, and through storm drains. Another major cost associated with road salt is that it can make wells unusable and need replacement. The New Hampshire Department of Transportation replaced more than 424 private wells contaminated by road salt from 1983 to 2003 at a cost of $3.2 million. Salt in groundwater can have a potential impact on human health, especially those who have high blood pressure. The EPA recommends that people on low-sodium diets should not drink water exceeding 20 milligrams per liter, and they require that all public water systems report on sodium levels higher than this concentration. However, salt concentrations in drinking water are variable and can't be blamed on road salt alone. Sodium can also reach water supplies through sewage, seawater, natural salt deposits, oil field brines, and agricultural chemicals. Road salt contamination in surface waters is mainly an issue for the hydrology and ecology of lakes and ponds. Water contaminated with salt is higher in density than fresh water and will settle at the deepest part of the water body where current velocities are low. This can lead to a chemical stratification, which can hinder turnover and mixing. This in turn prevents dissolved oxygen from the top layers of the water from reaching the bottom layers, and prevents the nutrients from the bottom layers from reaching the top layers, leaving the bottom layers of a water body void of oxygen and unable to support aquatic life. Salt can pose a threat to the existence of species in lakes, streams, ponds, and on land. Mammals, vegetation, insects, fish, amphibians, and more can all be impacted by road salt. Birds can mistake salt for seed, which can be toxic and result in death. Deer and other mammals are attracted to the salt on the road, causing an increase in car accidents involving wildlife. Elevated levels of salt in plants can cause an osmotic imbalance, which can inhibit a plant's ability to grow roots, uptake water, and uptake nutrients. During the 1950s in New Hampshire, approximately 14,000 trees along 3,700 miles of salt-treated highways died and needed to be removed. Vegetation close to roads and highways are most impacted by road salt and are also an important buffer for retaining and processing stormwater pollutants besides salt so that they don't reach water resources. Aquatic organisms exposed to additional salt or to extensive fluctuations of chloride levels are vulnerable to survival, growth, and reproduction risks. In a study published by the Ecological Society of America, it was found that road salt had traveled up to 172 meters from the highway and into wetlands. It was also found that the egg mass densities of spotted salamanders and wood frogs were 2 times higher in forested vernal pools than in roadside vernal pools. I took a closer look at the effects of road salt on vernal pools in Connecticut by going out into the field and shadowing Mary Shaw and Eva Nelson, undergraduate students at the University of Connecticut who were helping conduct a study on the effects of road salts on ephemeral wetland ecosystems. We went to 4 different sites in the Windham and Tolland counties and counted wood frog egg masses and measured the conductivity in the water. It seemed that the biggest struggle when leading the study was getting permission to enter private property and perform testing because either no one was home or the landowner said no. Another difficulty was finding vernal pools that were close to a main road that is heavily trafficked, which would be an indication that road salt was used. Once at a site, a GPS point was taken so that the location could be retraced. A sketch of the shape of the pool was made in a field notebook in order to keep track of where the 2 counters started and ended. Other aspects of the study include studying mosquito populations and salt tolerance, and the impact of salinity on the solubility of gases in water. With all of these environmental concerns, one may ask, what are the alternatives? Some towns in Michigan and Wisconsin actually claim to use a variety of odd substances, such as cheese brine, beet juice, and molasses. Although these substances still require some concentration of salt in them in order to be effective, it would dramatically reduce the amount of salt going on the roads. A company called Golan Plastic Products has created a system of heating elements that can be placed under sidewalks and driveways in order to melt snow and ice. Solar roadways have also been proposed that contain heating elements powered by solar for melting snow and ice. However, it would come at a large price. It would take more than 10 billion solar panels to cover the more than 3 million miles of roadways and 25,000 square miles of driveways and parking lots in the U.S. at $6,900 a panel. This process of snowmelt may also interfere with the natural hydrology of rivers and other sources of water due to an unnatural accelerated method of melting. The most simple and current solution to reducing road salt use is to be more cautious of the amount of salt being distributed and the amount of salt that is actually needed. Equipment such as regulators and sensors on salt trucks can measure the amount of salt needed on the road, which can be an important step towards reducing road salt use. Overall, there is still an undeniable need for road salt to get us through tough winter storms. It allows for safe traveling during the winter months, which is vital to our economy and everyday lives. It is crucial to note the environmental impacts as well as economic costs that road salt can cause, and with this recognition, steps towards reducing salt use will be of higher importance. We may not make an immediate notion to end the use of road salt, but as it becomes a pervasive issue to our water resources, we must consider better practices of road salt application.